Okay, we're going to talk a little bit about lenses. The first thing about lenses we're going to talk about is focal length. So basically, this shows a cross section of a lens. You can see there's quite a bit of mechanism in there. There are also several different pieces of glass that are ground to particular focal lengths. And basically, the lens is what gathers the light and forms an image on your sensor. Now, DSLR lenses can be large, complex. You can have zoom lenses that change the focal length. You can have specialized lenses. You can pay up to $10,000 for a lens or more. But basically, this is the principle. If you're using your phone or your tablet, the lens is probably a lot smaller and also a very short focal length. Most phone cameras do not have zoom lenses that can change focal length. Now, if your camera has a digital zoom, I would say don't use it because all it's really doing is cutting out part of the image and magnifying it. And you can do that yourself in Photoshop and probably get better results. So don't do the digital zoom, just use the lens that's in there. The focal length of the image of the lens determines the size of the image. So the longer the focal length, the bigger the image. A normal lens theoretically sees things about the same size that your eye sees them. Wide angle lens, as the name implies, gives you a wider field of view. You can get more in the picture and actually makes things look smaller. And they do have other features, which we'll talk about in a minute. Telephoto lens brings things closer. The larger the sensor, the longer the focal length of the lens required to give the same angle of view. You don't have to worry about that unless you're moving between different cameras. Now, focal length, these are taken with a camera that has sort of a medium-sized, it's a DSLR with sort of a medium-sized sensor. And just to show you what happens with different lenses, this is a wide-angle lens. This is the quote-unquote normal lens. So basically this is about the same size as things would have looked with your eye if you were standing at that point. This is taken with a telephoto lens, so things look like they're closer. Okay, different focal lengths also have other effects. Wide-angle lenses tend to exaggerate the image perspective. So things in the foreground look bigger, things in the background look smaller, makes it look like there's more space than there actually is. So it gives you an impression of depth. And also you'll notice that when you tilt the camera up to get the whole building in, it looks like the lines of the buildings are converging. That is also exaggerated with a wide angle lens. So foreground looks bigger. Not great for portraits, unless you want your subject to look like they have really big noses. It also exaggerates the size of the part of the face that's closest to the camera. Telephoto lenses tend to make things look closer together. Now, these are kind of extreme examples, but if you've ever watched car races or sports on TV and wondered how things could be so close together, it's because the telephoto lens is compressing perspective. And you can see it makes the buildings look really close together here. Okay, another function of lenses is controlling exposure and what's called depth of field. And this has to do with these little metal blades. If you look at the two pictures of lenses here, it's called, you'd see the term f-stop lens opening aperture used interchangeably. Basically what it's referring to is the size of that opening in the lens. Now, most phone and tablet cameras do not have apertures, mainly because the lenses are so small. You will find this is mostly, a few of them do. This refers mostly to DSLRs. The lens opening, or aperture f-stop, is designated by this number. So the smallest number is the largest opening. Lets in the most light. So you have to remember that this controls exposure as well. And basically, the smallest number that you'll find on your lens is the largest opening. As the numbers increase, the size of the opening gets smaller. And you can see at the bottom one, as the lens is closed right down, it's a very small opening. This controls the exposure. So obviously the smaller opening will let less light in. It also controls what's called depth of field. Depth of field is defined as the range of sharpness in your photo. And this is an example of depth of field. So we have this group of people standing for some odd reason in an alley, having their photo taken. And you'll notice with the lens on the largest opening, the guy in the middle is in focus, the guy in the foreground and background are out of focus. That is because this has shallow depth of field. When the lens is closed down to f16, which is a small opening, we now have enough depth of field to keep everybody in focus. This is extended depth of field. The trick with extended depth of field is 1/3 of the depth of field is in front of and 2/3 behind whatever you're focused on. So the camera is still focused on the guy in the middle, who's actually the guy on the right of the photo. But you'll notice that we now have enough depth of field to keep everybody in focus. Focal length of the lens affects the depth of field. This is a wide-angle lens. Wide-angle lenses have more depth of field than telephoto lenses. This is a telephoto lens. You can see the depth of field is so shallow that even the twig right behind the bird is out of focus. Depth of field is actually infinite at one point. So if you're using your DSLR and your subject is, say, 25, 30 feet away, it doesn't actually matter what f-stop you're on. Everything's going to be in focus with your camera set on its normal setting. So 50 millimeters for a full frame camera, or about 34 for a DSLR with that APS-C sensors. So infinite depth of field. The closer you are to your subject, the less depth of field you get. You can see how shallow the depth of field, even the bottom of the leaf is going out of focus. Extended depth of field, when you want everything to be sharp, you're going to use a smaller lens opening. So remember, larger number, smaller opening, more depth of field. Shallow depth of field is great for getting rid of distracting backgrounds. If you're shooting with a phone or tablet, you will have a lot of depth of field because the lens is very short focal length. So you'll find that you're more likely to have extended rather than shallow depth of field. Only with super close-up things with a phone camera will you have shallow depth of field. This is called bokeh, and it's the aesthetic quality of the out of focus parts of the image. So if you look at the blurry parts, throw this in here. So if it's not sharp, why is it not sharp? The bottom left one is everything's pretty sharp. The top right one is actually camera motion. You can see there's almost a streaky quality to camera motion because you can see what direction the camera was moved. The bottom one, on the other hand, is not enough depth of field and incorrect focus. So you can see the flowers in the foreground are out of focus. Throw this in here. So if it's not sharp, why is it not sharp? The bottom left one is everything's pretty sharp. The top right one is actually camera motion. You can see there's almost a streaky quality to camera motion because you can see what direction the camera was moved. The bottom one, on the other hand, is not enough depth of field and incorrect focus. So you can see the flowers in the foreground are out of focus.